Welcome to the latest episode of Beyond the Bot, where we break down the latest and emerging technology and how to put it to work in your business. I'm Tony DeHart.
And I'm Stephen King.
And today we're going to be breaking down some exciting news. We got a first look at Figure One's Helix this week, which is the latest in humanoid robotics. To break this down from a technical perspective, we had to bring in Bhargav Bompalli, our senior computer vision engineer and robotics engineer at Blue Sky Robotics. Bhargav, thank you so much for joining us.
Thank you for having me.
So in some ways, I'm feeling a little bit of deja vu because we've seen some of these advancements with humanoid robotics in the past, in particular with Tesla's Optimus bot. We broke down that demo in a previous video. Some folks a little bit skeptical of that technology. Stephen, how is this release different?
Well, for one thing, when we were talking about the Tesla ones, there was a party situation where everything was presented as if it was AI driven. And there was a lot of great AI stuff there, but some of it was done by human remote controllers. In this case, we have a video from another company, and they also released a lot of information that Bhargav was able to dig in and actually understand the things behind it, which gives us a higher level of trust of what we saw.
So Bhargav, when you were researching this and looking into kind of the deep dive technical details behind this, are you able to kind of follow exactly how they pulled this off?
Yes, it's very exciting technology that they use to pull out this demo, which makes it the fact that they publish all these findings on the website and put out a press release on this makes it more trusting to the public as to whether the demo what they saw was real or not.
And repeatable. That's, I guess, something that's really important here to build that trust. Mm-hmm. Folks can kind of follow exactly what's going on there. Stephen, is this, before we get into the technical deep dive of what's going on under the hood here, is this what we look at as the future of robotics?
There's a lot of excitement around humanoid robots. We live in a human world built around our form factor. We have stairs and we have things. And so there's value in having a robot that can go over obstacles and use things that we've built for ourselves as humans. There's also this kind of dream of Rosie from the Jetsons and having this robot that can do so many things that help us in so many different ways. And it's like multitask and can do anything. And so I think there's a great drive towards that direction. But it's not the only one. I think you're going to see a lot of task-oriented robots, things that are more efficient at doing a very specific purpose or specific task. And so those are great value, but we can't ignore the fact that they just got a huge $1.5 billion investment, making them a $40 billion company. It's coming, and they have a lot of money to solve a lot of hard problems.
So, Bhargav, in many ways, this is exciting from a technical perspective because it's a first look at Helix. That's the vision language model that they've developed in-house, a development that allowed them to break away from their long-term partnership with OpenAI. Can you tell us a little bit about what a vision language action model is and how that allowed them to break away from OpenAI?
So I'm actually really excited about this demo because it is a flawless execution of a VLA, which is a vision language action model. So basically a VLA, as the name suggests, uses vision and language, which is pre-trained on something called a VLM, which is a vision language model, and then combines the two in order to output a action. So like in this case, a robotic action.
So we're not, interacting with robots from using voice is not necessarily something new, right? Like we're all familiar with using an Alexa, right? How is this different from that?
So basically, it's kind of like, in a sense, Alexa is like the first step of it. So you ask Alexa, what's for breakfast? Or name me a breakfast recipe. Alexa will respond a recipe to you. But with the vision language action model, you can tell it what's for breakfast or make me a breakfast. It will tell you what the breakfast is and proceed to go ahead and make it, combining what it can see and its robotic movements.
Now, Stephen, from an interaction, human-robot interaction perspective, obviously this is a big step forward from the way that we traditionally look at robotic interactions that are controlled via a teach pendant or a program or something like that. How does this shift towards more, natural language control going to impact the way that people actually use robotics?
First of all, the field of human-computer interaction is growing significantly, especially when we talk about robotics. Now we have a human form to engage with. So yes, we have the ability to use the spoken word. We could also, historically, we've done teach pendants, or we've done kind of code-based integrations and engagements with robotic arms. But now we have something that looks like a human. There's an expectation that we interact with it like a human. And so this is one of those things where we're going to have to figure out what's the best way to do this. And we have an example here in the video of where it shows how people expect humans and robots to interact. And so we see some behaviors that have been programmed in to make it more realistic, or at least more seemingly less strange.
That's interesting. So in many ways, kind of similar to the breakdown between like, more generally intelligent robotics, task-oriented robotics. It seems like we have another tool in the toolkit, and it's all about finding the right tool. Stop.
Exactly. That's exactly. It's a big multi-purpose tool. So if I were to give it an analogy, I'd say it's kind of like the Swiss Army knife. The humanoid robot is a Swiss Army knife. It can do many things, and it has lots of different value. And sometimes you really need that Swiss Army knife, and that's a great place. But then there's also times where we want to have a knife for a specific purpose. So if I'm chopping vegetables, I want my 7-inch chopping knife, right? If I'm filleting a fish, I want a fillet knife, right? And I want something different than my Swiss Army knife. But at the same time, there's a lot of times where that's valuable and it can get the job done. So I think what we're going to need to do is kind of see how humanoid robots develop and see what is their great purpose and what problems are they solving and how are they solving the problems, and see is it better than the way we're solving it in other ways.
That's super interesting. Bhargav, as you mentioned, in many cases, this is one of the first times that we've seen one of these VLAs in action that is, able to have, kind of this real general intelligence, right? Like we saw in this video, it's, interacting with new objects that it's, in some cases, never seen before.
Even though this is the very first time that you've ever seen these items, I'd like you to use your new Helix AI and try to reason through where you think they belong in the scene, and then work together to put them away.
How is it doing that? How are we able to, recognize and interact with those objects?
Yeah, it's interesting because in the video, you hear the person saying, look at these objects you've never seen before. So they're trying to emphasize the fact that these are brand new objects that these robots have never seen before. But the reason it's able to perform the task on these objects is because it's trained on it's a 7 billion parameter VLM model, as I mentioned earlier. So I know 7 billion sounds like a lot, but it's actually like not that big. There are like 30 billion parameters, 65 billion parameter models out there. So it's still a lot, but it's very efficient at this task. So basically, it has seen like millions of images from the internet, and so it is, because of all this knowledge, it's able to generalize pretty well and know what novel images of items look like without actually seeing them.
Maybe had never seen a ketchup bottle before, but it had seen images of types of condiment bottles, and so therefore it knew what to do.
Yeah, exactly.
And those images already mapped to actions and connected with the verbal cues that would initiate that. It's really tying all these things together.
Exactly.
As I've watched this video over and over again, one of the things I was curious about was in the refrigerator, there was actually another condiment bottle laying on its side in a very specific bin. And it chose to put the ketchup bottle with that, right? And so you can just see how it's reasoning and how it's like making decisions based on the environment it's been trained on and the environment that it just sees right in front of it.
Now, that training process is what I want to hone into next, because, we're used to building AI models at Blue Sky Robotics. I think we've all had the experience of, going through and doing this manual annotation where we're, kind of drawing bounding boxes over, large data sets of images to, kind of train the object detection pieces of our AI models. How is the training process for a VLM different?
So Figure has stated the training process for Helix is through over 500 hours of teleoperated data. So this means that the robots have been doing actions, over 500 hours of actions, such as like picking up items, placing them somewhere. And each action is actually mapped to a text prompt. So for example, one would be like pick up this cardboard box and place it on a high shelf. And what's actually interesting, so you did mention that we manually annotate all our images. Figure has used a method which automatically, it's like using another AI model to generate these prompts. So like when it said pick up the cardboard box and place it in a high shelf, that was actually AI generated prompt as well. So that really helped speed up the training process. And you can see this really well when the robot picks up the ketchup bottle and places it in the fridge. It probably went back to that knowledge of this robot or this ketchup bottle is in the same shape as this cardboard box. So it uses that knowledge to figure out how to grasp the bottle and then place it on the fridge, just like it would place it in a high shelf.
Bhargav, super interesting to get some insight into what the training process was like here. And of course, when we talk about training, we're talking about training Helix, which is really the brains behind the operation. And, we saw that deployed to to two robots. In some cases, they were collaborating and helping each other, and in some cases, kind of communicating. It looked like they made kind of eye contact at some points. Yeah.
So it's actually really interesting. Even though it looks like they were communicating, they weren't actually directly talking or communicating with each other. So Figure has mentioned there is no communication protocol between the two robots. They're actually using one single neural network between the two. So this means both robots have the exact same knowledge and database in order to carry out tasks. All they know what to do is perform the task that has been asked of them. So using the cameras, they know that there is another robot beside them. They are aware of what the other robot is doing. So using all that knowledge put together, they can essentially collaborate. But at the same time, what they're doing is they're just carrying out the task that they're asked of.
So they're working independently, but with sort of an aligned understanding of the task.
And I think this is really fascinating because essentially you could have a group of robots to solve a problem, right? And you have 6 cameras on each robot. Now we have 12 cameras to use. So that's more information that this neural network is able to take in and use, right? And so if you think about it from a human perspective, maybe an analogy is just like my brain has 2 arms and I can use it. I don't have a brain for one arm and a brain for the other arm. We have one brain controlling both arms, right? And so in this case, we have one network controlling both machines, and they work together using all of the resources available to them.
Now, I can't get past this moment where they make eye contact. I mean, if they're not actually communicating, what are they doing?
So we don't have any insight specifically as to what the engineers were thinking here, but I think this is part of that human-computer interaction and understanding the psychology of robots working together alongside humans. And so I think we have to have, if we're going to have a human form, they need to have some of the behaviors of humans. And so this is a case of where I think we see that. And I don't know if they hard-coded this and programmed it for more of the video, or if this is just part of the programming of the way the network works is like, hey, we completed a task together, and they look at each other to give you that. Maybe there's going to be a high five one day, right? But I think we have to figure this out. And like the way humans work with robots is going to be really important for adoption. If people are going to adopt it, they have to feel comfortable with it. And this may be one of those steps that help to that.
And we've seen that with our own projects, right? Where when we give a robot a name, these kind of like baby steps towards personification, people tend to work with them, not against them.
Yeah, when we're deploying robots, we're doing this in a way where people are using them alongside other workers. And so we want them to be a team, right? And so one of the things is we personify them, right? To the point of when you see one of your robotic arms laying on its side because it just hasn't been installed something yet, it feels weird. Like it feels like something's wrong and it's sick or something. And so I think this is something that we naturally do as humans. And I think as we interact more and more with robots, we're going to see this type of interaction with them.
So, Bhargav, if they aren't actually communicating, what can you tell us about the AI that's actually running under the hood? Is Helix, kind of just one giant VLA model, or what's the story there?
So this is actually another big breakthrough for Figure. So I think this is how they got their name Helix, but basically it's 2 AI models. So 2 AI models, both running asynchronously in order to perform their functions as smooth as they did in the demo. The first one, they called it S2. So that one is kind of like the brains of the robot. So S2 is what is running the VLM, which is a visual language model. And so it is constantly analyzing what it sees, so visual data, and it's also analyzing its robot pose. So it knows what it sees in front of it, and it also knows what position the arms are, where the torso is, and it feeds that information to itself and to the brain. The second model is called S1, and this is like the muscles of the robot. So basically it uses the same visual input as S2, so the same camera input, but this time it is outputting fine motor function. So depending on what it sees, like a ketchup bottle, for example, it's using this, it's a transformer model, this transformer model to convert that into how to pick it up.
Wow, that's really interesting. So in some cases, it's a lot of the same kind of underlying AI principles that we use in our solutions. Stephen, are we likely to see humanoid robotics coming to Blue Sky Robotics solutions anytime soon?
Well, I'm not going to say no, right? I think there's opportunities for different tools for different jobs, right? The majority of work we're doing, the humanoid robot is not the most efficient way to do it. And so if we're doing the same task over and over, it's a known task, a known entity, then automating that with a kind of standard solution, the easiest, most less complex solution is the best one. And so most of our work uses computer vision. It uses AI to interpret and understand its environment, but we're having a single arm do the action rather than a humanoid form. But maybe there's a day where we're going to do more of that.
Yeah. Well, thank you so much for joining us, Bhargav. It was a pleasure having you. And thank you so much for tuning in. We'll see you next week for another episode of Beyond the Bot, where we break down the latest and emerging tech and how to put it to work for your business.